All good? All right, folks, let's get started. Can you, I don't see this will work still, right? Okay. Welcome, good to see you again. I thought we had a nice morning, lots of good discussions. Let's continue it here and having a nice, engaging, open discussion about early science, which the team thinks of as everything leading up to and through the first data release, which will happen after taking 6 months data with LSST, for LSST with the system after we get going. This is mostly not my work, and the experts, fortunately for you and me, are here. Keith Bechtold, who's leading the science validation work for Rubin, Eric Blum, who's our alert generation lead, Melissa Graham, who's the community science team lead, and Leanne Guy, who unfortunately can't be with us, but is online. And I invite Leanne to jump in at any time. Leanne's the deputy project scientist for construction and the associate director of system performance and operations. Okay, reminder of the code of conduct. Let's have an honest, open discussion. Let's respect everybody and work together. And I think I don't need to go over this. You've probably seen it a few times today. Respect people's preference on how they like to interact. In-kind or in-person participation reminder. I don't think we need that right now. It looks like everyone who wants to be here can find a spot. Virtual participation, if you're online, take a minute just to scan this slide and make sure you're ready to go. Either questions on the Slack space. In-person participants, we're gonna have Phil Marshall up there, and I think Agnes Verte over there. Help them pass the microphone back and forth. So it's a big room, and it just to keep the discussion going. Reminder that no one can hear you online unless you're speaking through a microphone. So please don't start your comments until you have a mic once we get to that point. All right. Early science is defined as any science enabled by Rubin for its community through and including the first data release. And we really do want to make sure that we have the data products and the services and the tools and the collaboration in place to make an impact early on as we go through this. It's been a long time coming, not the least of which because you all want to do science, but our governments have spent a lot of money, and it's realistic to expect that they want to see some impact early on. And I think we can do that together. And so we just need to work on that together to make sure it happens. If you want to follow along with more details as we go forward, this is a living document, RTN 011, the plan for early science. And you can easily find it with ls.st/RTN011. And this will be updated. It's probably a little more stale right now than even this discussion will be, but we'll get it updated soon, and you can follow along as we go forward through commissioning and into early operations. There's a nice link here if you want to cite it for a proposal. This is particularly useful as you maybe look toward proposals in November to funding agencies about the science you can do early on with Rubin. And so you can cite this document as the authoritative place for what Rubin thinks we're going to be doing in the next year or so. So what's our motivation? We want to enable high impact science prior to the first data release, both before and during the first year of regular survey operation. We want to provide access to static sky as well as transient and variable sky at the time domain science. And we'll show you, we'll talk about how that can happen in this hour and of course going forward. We want to do that also by enabling, of course, the alert generation during commissioning and then slowly ramping it up and steadily ramping it up. So it's regular. I talked about this. I was a little confusing maybe this morning. We don't expect right away to have the full alert generation routine, regular alert generation as we start. Again, that's because we won't have the full sky covered with templates, but we will get there. And the idea is that as soon as possible, the limited alerts that we can generate will be regular and continue to go and continue to grow as we go forward. Okay, one of the things that will fuel early science are the data previews. There's 3 data previews, 0, 1, and 2. We've talked a lot over the last year or more about DP0. So the reason that's important for early science is it really trains up the community and the observing team on how to process data, how to get it out on the science platform, how to put it together with the analysis tools on the science platform and do science with it. So if you haven't yet engaged with DP0, I strongly recommend that you do so, because you can do that right now. You can go sign up for an account right today. You could start learning along with everyone else. Doesn't matter what level you're at, where you're starting, we will bring you along and make sure you get ready before the real data comes, which will be first with data preview 1, which is commissioning camera data that will be coming within a few months, taking the data. And then as we go through into the new year and we get through the first light celebration, the ops team will present a data preview on the science platform from those data for your use and training going forward. And then, of course, as we start taking data and move through into operations, we will take all the science validation data that was accomplished at the end of the commissioning phase and package them into DP2. That will come out before data release 1, but it will be after we start operations. And so there's that middle area between DP1 and ComCam and DP2 that comes out after we start operations. That's part of the discussion today. What will be available? There'll be some things available in between there, and that's what we want to talk about. And some of that is not completely set yet, including exactly the timing and content of the alert stream, the World Public Alert stream. One of the things we have to do as we go forward is understand how we most effectively generate templates in this period before we have the full sky coverage after the first year of observing. And we'll do that by generating templates incrementally, and Eric's going to talk about that later on this afternoon in this talk. And then we'll end this whole process with data release 1, which will be the first 6 months of data taken through the first year and processed and delivered at the end of the first year of operation. So this is what that looks like graphically. If you were at the plenary this morning, you saw this. We'll start this timeline after the technical system first light occurs early next year. And we'll move forward with the system optimization, full rehearsals, and then we'll start operations late in FY25 or late in 2025. This data preview will come out after the first look media event. What's under discussion right now is what of that first look, or what will the first look of ELIS's TCAM data be like? And we'll talk a little bit more about that today. We will start putting out visit images. So these are the nightly images, each visit that we come out with, processed and with catalogs, starting in operations. And that will be kind of a gradual release, getting to the point where we're confident that the content of those data products is what we want to see. And then eventually, before about the time of data preview 2, at least, we will start regularly do that with every visit image that we put out. At the same time, as we get through the commissioning phase, the end of the commissioning is the science validation phase, we'll start regular alert generation on the places in the sky where we have templates and in filter coverage that we have. So it won't necessarily be at the minimum latency, which is our design goal, of course, 60 seconds. And it won't be over the whole sky, but it will be regularly starting to put out alerts, and we'll just keep growing that until we reach full alert generation after data release 1. This is the timeline for those data releases, intermixed with specific milestones on the project or operations side. So there you see the system first light. That's the technical first light for the camera and telescope system that the construction project will declare done early next year. We will put out data preview 1, which we'll have taken the data for in just a few months going forward. Then we'll start operations about a year from now. The start of the survey will happen as soon after that as we believe they're ready. We had a discussion with the SAC this afternoon. You can, I hope, see a recording or see notes about that, where we talked about what it means to start the survey. And there's a lot of good discussion about specific criteria to make sure that we're taking really good survey data by the time we declare the start of the survey. Then there'll be the science validation data coming out as DP2. Oh, sorry, we'll start regular alert production in the sense that I just described, and then science validation will come out, and then DR1. And then after that, every year, the plan is to put out a data release that includes all the data taken up to that point. So by data release 3, we're talking about 2.5 years of data, and we'll continue to reprocess all the data going forward in every data release. So just a few words about what it means to get to that point where we're in operations. This is a current schedule, a view of what it will look like to close out the construction project. So starting very soon, we're going to work with the agencies to understand what is the process and the criteria for finishing the construction project, which are well known. There's science requirements and system specifications that we all know about and have been working toward for many years. In November for CCR1, so this is a 4-stage closeout and start operations process, we'll lay out the scope of things that we're going to complete, make sure everyone's on board when things will happen. By CCR2, which is less than a year from now, we will show the idea is that we'll show a bunch of things already validated or verified for the system, right? So you can imagine we have a long list of things that we have to check off, a large number of these that we already know about that could have been tested at the system level or the subsystem level or early in the system level, maybe from ComCam or something else, will be done. And that will allow us to focus on the fewer things that were required to make sure we're ready to go for the survey in the last part of this phase, which would be then reviewed and passed off on by the CCR3, which would be about a year from now. And then there would be a final administrative closeout on the project, just tying up all the loose ends, contracts, and other things while we start the survey. So at that point, that's all kind of preliminary. I'd like now to hand over to Keith Bechtold to talk about what our plans are for the commissioning cam data, and that will give you a real sense of where we'll be at by the time we hit the end of this year.
Is this on? Okay, yeah. Good. Thanks, Bob. Okay, so I'll give a description, an overview of the types of on-sky observations that we're expecting with ComCam. And this will be, this would make up the superset of data that could be included as part of DP1. So the on-sky commissioning period for ComCam is expected to last roughly 8 weeks in the September-October timeframe. And then after that, ComCam is removed from the telescope in order to prepare for the LSST cam installation. So that's what sets the timescale. I should say that most of the on-sky commissioning period, or probably much of the on-sky commissioning period will be devoted to engineering activities. In particular, LSST cam has wavefront sensors that are offset from the rest of the focal plane, but ComCam does not. And so if you want to measure the wavefront for the active optics system commissioning, it means that many of the observations will be taken with the full focal plane, intra and extra focal. This is useful for AOS testing, but those images won't be useful for science directly. It's part of the commissioning. And so we expect to have a higher fraction of those full focal plane images offset during ComCam commissioning. I will say that even a few hours of good quality imaging across a few nights will be extremely informative for science pipeline commissioning. And so we're looking at the ComCam on-sky period as an opportunity to prepare ourselves for commissioning with LSST cam. So this is a schematic showing a possible timeline of the active optics system commissioning that Josh Myers and Sandrine Thomas put together. So it's set in chronological order. So it begins with the ComCam being the laser pointer. But it begins with the ComCam on-sky first photon. So these are literally the first night sky images with ComCam installed. And at that point, the system has not yet been optically focused and aligned. So from that starting point, the goal within the first week or so is to get to the point where we have the pointing, the tracking, refining the optical alignment and the focus. And so we expect to start with observations that are close to zenith, and then we begin exploring a wider range of parameter space. So starting to be able to routinely take observations over a wider range of air mass, basically off zenith pointings, improving the number of degrees of freedom of the active optics system that have been tuned up. And so there's a whole variety of tests that are happening during that first month to begin optimizing the system. And then as we get, likely into the second month or so, we expect to be getting closer to the, a consistent image performance, as far as we can get with ComCam over a broader range of air mass. And so the AOS team has done a lot of work into preparing this, and this is just a very quick schematic of what that could look like. And so where the science observations would come in is as the image quality is improving and the consistency, we expect the duty cycle for observation to be commissioning the science pipelines to be increasing as we move to the right on this timeline. So as part of the whole test program with ComCam on-sky commissioning, several of the tests are specifically designed to start exercising the science pipelines. And so I've listed some of those here in the approximate order that we expect that we could usefully conduct those tests, given the progressing maturity of the system. So at the very start, we will take any in-focus images and attempt to push them through single frame processing, right? So just take the individual visits. As long as they're close to in focus, we will attempt to process them. Then we expect to start taking observations like exposure time scans, bright star scans. We're just looking in one region of the sky and kind of doing more engineering type tests, but these will be start of the science, dedicated science observations. And then we'll move to what I'm referring to as the dense dithered star fields. So these are observations where you have some pointing center and you're taking a series of dithered observations around those pointing centers on a range of different timescales. Beyond that, we would basically try to build up exposure, so a deep field. And then if we have time, we'd like to do a survey covering something like 10 square degrees, basically to try to increase the area, particularly to test the alert production pipeline. So the observations that are further down this list might not be completed before we determine that ComCam needs to be removed to prepare for LSST-CAM observations, but this is a nominal target list. So in terms of the bands and the fields, that's summarized on this slide. So for ComCam, the filter exchanger has 3 slots in it. So three different filters can be loaded at a time. So we're initially expecting to have 2 of the G, R, and I filters loaded, plus a pinhole that can be used to measure scattered light inside the dome. Once we've completed some of that engineering testing with the pinhole, we expect to load the G, R, and I filters into the exchanger. And then once we've understood the image quality with those bands, we would like to swap in the U, Z, and Y filters. So our goal is that we have all 6 of those filters available and that we would eventually observe in all of them by the end of the ComCam on-sky period. In terms of the fields, we're expecting that initially the image quality will be best near the zenith. And so we'd be taking the observations in a kind of a small region around the zenith. During the AOS testing, a lot of the observations are specifically designed to explore the parameter space of the telescope in azimuth and in elevation space, altitude. And so those observations might be scattered on the sky in terms of RA and DEC. But once we're able to start getting into the more dedicated science programs, our goal would be to take repeated observations of a handful of fields. They would be designed to span a range of stellar density, to have at least some fields near the ecliptic plane, and also to have some fields that are overlapping external data sets like deep space-based imaging, many-band photometry, spectroscopy. In terms of the duty cycle for the science pipeline commissioning programs, again, we'll try to run the single frame processing on every in-focus visit that we can to have a heartbeat of characterization of the performance. Once we get past the optical focus and alignment, we plan to interleave more of the science programs. So we could actually have multiple different types of observations on a given night. You might have a few hours of AOS testing and then switch into science programs, for example. But in general, we expect the duty cycle for the science observations to be increasing throughout the ComCam period. I'll mention that for the implementation of these science programs, as much as possible, we're trying to use the feature-based scheduler. So the same type of logic that will be used to conduct the LSST survey. And part of this is that we'll make it easier for us to easily transition between engineering type observations and science program activities, just as opportunities allow. For the types of observations, I'll just call out one of these as an example. This is kind of the bread and butter observation that we plan to take during ComCam. It's called a dense dithered star field observation. And the plot that's shown here is if we were to conduct this science program for one full night at the end of September is where this example comes from. So you've got air mass on the vertical axis and then time during the night on the horizontal axis. So what's being shown here is that we'd be taking observations, for example, 20 visits in each of the G, R, and I filters, and that would be one sequence. That would take about 40 minutes. And so you can kind of see those individual tracks that are for different fields, color-coded. And then we try to observe the same field at a range of air mass during a given night. And the purpose of this is that we would have multiple repeated observations to test the internal calibration. And we would try to apply translational and rotational dithers so we'd get the same stars appearing at many different locations across the focal plane. And then by doing this type of observation, for a few hours a night over a couple nights, you'd be able to sample temporal cadences ranging from minutes to hours to nights. This is what one of those individual fields might look like in terms of the coverage. So it's roughly a square degree. The ComCam field of view is about 3/4 of a degree on a side. So once you apply the dithering, you cover an area of about a square degree. And this example is showing the 5 sigma limiting magnitude if you were to have a coad from about 40 dithered visits in the G band, for example. So this is something that you could easily acquire within a night for a given field. In terms of the field selection, the idea is that we would have a set of fields that are distributed across a range of right ascension so that there's always fields that are rising and setting that we can choose from at any given time. They would intentionally be spanning a range of stellar density so that we can explore how that interacts with the science pipelines and our ability to do the calibration. We would try to have a mix of fields along the ecliptic, which is shown by this dashed black line, and also fields to overlap external reference data sets like the LSST deep drilling fields. So this is just an example, but it gives a sense. This particular example comes from when we were doing the operations rehearsals for commissioning. So these are just examples of what that data might look like. So these are simulated individual CCD exposures that were created for the purpose of doing the operations rehearsal for commissioning. But why I picked this example is that it shows fields that span a range of stellar densities. So the field on the right has about 10 times the stellar density as the field on the left. So we would try to basically span this parameter space. This is if you take those observations and you build a coad over just a few hours of data, you'd get something like this. So the right panel here is just a zoom in on that little inset, which is only a fraction of the ComCam field of view, but gives a sense for what the image quality or what the data might look like. So during the ComCam on-sky commissioning, just a few caveats. The delivered data quality is likely to be more heterogeneous compared to the full survey observations, and this is for a couple different reasons. One is that we will be doing many of these engineering and commissioning activities for the first time. And so there's a learning process. Much of the time will be dedicated to the active optics system commissioning, image quality monitoring, calibration systems. These will all be being commissioned in parallel. For ComCam, as I mentioned before, there's no wavefront sensors. So that makes it a little bit more challenging to do some of the closed loop testing. It's also a little bit more challenging to fully characterize all the active optics system degrees of freedom with the smaller ComCam field of view. So there's some optimization that we'll have to wait for LSST-CAM. We expect that there might be image quality contributions that are related to dome seeing, telescope, jitter, and tracking that we'll be working on throughout this period. The instrument model for ComCam is not as fully developed and tested as for LSST-CAM, where we have much more electro-optical testing in the lab. And the calibration systems, including the flat field screen, will be commissioned in parallel. So all of these will be happening simultaneously. Still, I think I'd like to convey that we are extremely excited about this data. It will be a tremendous learning opportunity and really help us prepare. And we hope that it will yield some data that will be useful for broad science validation purposes as well, hopefully in DP1. Any questions? Yeah.
Yeah, I will say that if you have questions for Keith or Bob, you can ask them in the Slack and they can answer them there. And then we'll do a Q&A session for all the speakers at the end. That work? Oh, yeah, we'll take one now.
I'll just ask it. Yeah, hi Keith. What was Sitcom's definition of dense in the dense dithered star field? Because it seems like the pointings you showed deliberately avoided the galactic plane. Is that deliberate?
Sorry. So dense in this case is referring to the density of the dithers. Basically,
the dithers are dense.
many repeated observations in the same field. And again, the purpose here is to test the internal calibration and to verify that performance. Those observations will span a range of stellar densities.
Okay. The dithers are dense.
Yeah, is there any plans to exercise the difference imaging pipeline with ComCam, or is that waiting for LSST-CAM?
Oh, absolutely. Yeah. So that's also one of the reasons why we plan to take many repeated observations. So if I go back here, the idea is that we will be building templates as soon as we can. And then by having observations on timescales of minutes, hours, and nights, we will be able to basically test the difference imaging in real time. Then we'll also be able to slice the data in many different flexible ways. So we're working closely with the alert production team to understand what their needs are, and that's all been folded into this plan. So yes.
I realize part of the ComCam exercise is also to stress the compute system, and I haven't really seen any of that talked about yet. I know the LSST pipeline is pretty mature at this point, and there's been discussions already about difference pipeline stuff in one of the other sessions. But I'm just curious to how does the compute system and trying to bend it over sideways so that it works correctly when the full data pipeline come in this whole commissioning picture?
So we've actually been trying to test as much of this as possible during the past year, even before ComCam on Sky. So we've conducted 2 operations rehearsals where we took full nights of simulated data, basically following observations very similar to this, and also mixing in active optics system commissioning data. And that data started off at the data acquisition system on the summit and went through the entire data management system, including being sent to here, Slack USDF, for the processing in real time. And we actually had 7 different processing campaigns running in parallel. So we had real-time analysis that was happening at the summit and providing information to the observers. We had the prompt processing running difference image analysis and the solar system pipeline. We had nightly processing of all the visits, and then also multi-night processing of all the visits. So we had basically science data quality analysis that was happening on multiple different timescales. We intend to repeat that exercise with an LSST-CAM simulated data stream in the period between ComCam on-sky commissioning and LSST CAM on-sky commissioning. But these exercises were extremely valuable for us in terms of exercising all of that plumbing. Yeah. All right, happy to answer more questions offline if people have them. Yes, I should mention that, yes, in addition to doing this with simulated ComCam, we've been doing this with Oxtel for the past.
A catalog that has, oh, that's better. Could you hear me at all before? Okay, oh, okay, here we go, all right. And then any catalog that you find that has the word forced in it usually means it's force photometry. So the things have been detected already, and then you go back and do force photometry in all the images to get that. So these data products, they sort of have two time scales. The prompt products database time scale is 24 hours, you know, when we're in full operations. That's sort of the time scale that it gets updated at. And then you have the static sky data products, which sort of simulate the data releases that will come out later. And it says static science, but DIA is always redone for every data release. So actually the data releases, DP2 and then data release 1 and so on will also have time domain data products. They will have all the difference image analysis as well. Over on the right, there's a bunch of definitions, bunch of jargon related to the data products there for your reference. But a better reference is always our data products definitions document. You can always find it at ls.st/dpdd. I'm sorry, the link is not on the slide, because what this slide is linking you to is an abridged version of the massive data products definitions document. So this is a short slide deck that sort of takes you through what all the data products will be that Rubin will produce. And it talks a little bit about the compute resources that you'll have to access them. But the important thing about this particular data products abridged document is that it's DOI citable. So this is the thing that you can be using in your proposals for grant funding and that kind of thing. When you say, oh, Rubin is going to make this and this kind of image, I'm going to do this analysis on that image, and then you can cite this as showing that you don't have to make that image, you can just do your analysis on it. So this is there for you to cite in your proposals and to help you understand a little bit the data products. There's like a 10-minute video that gives you an intro pre-recorded. So if you prefer that to reading, just watch my video. All right, so data availability. So there's a bunch of nuances here to data availability. The first is that all the engineering, commissioning, imaging data does get held in embargo for 30 days. So that means that those data previews that you see are going to come out. They're always going to be at least 30 days after the data is taken, and that's true as the prompt processing gets going as well. Full focal plane scientific data forever. This is also in operations and throughout the survey. There's always an 80-hour embargo on the full frame images. So you will have access to alerts in 60 seconds, and catalogs get updated in 24 hours, but the full images, it is an 80-hour delay there. The data releases, those are the annual data releases, will be available to data rights holders and released via those data access centers that are listed. The alerts These are the real-time alerts, 60-second notifications of things detected in difference images, always world public all the time. And those go not to individual people, but to things called data brokers. There are several sessions. If that's a new term, there's a couple of sessions about alert brokers here at the RCW. And the first one, I think it's tomorrow, and it's specifically for broker users. So you'll get a selection of tutorials from the various brokers that will tell you how to access the alerts. Other prompt data products are available to data rights holders right in real time at the data access center. So when I said the catalogs get updated in 24 hours, that's available through like the Rubin Science platform and the data access centers, just like the annual data releases are. So same access mechanism for prompt products as for annual data releases. And then the proprietary period on those annual data releases does expire after 2 years. And at that point, everything that was in that data release now becomes shareable. So if you have international colleagues around the world, you can now share data from an older data release with them to do work, that kind of thing. Talk a bit about these data previews that will be part of the early science. So the purpose of having a data preview program is to prepare like both the community to get you used to accessing Rubin data, but also to prepare ourselves to make sure that we have the right resources to help you do your science. So it's kind of a twofold here for the data previews. There are 3, DP1, 2, and 3, or sorry, DP0, 1, and 2, indexed at 0. So DP0, it's all simulated. It's available now. The last release was made last year. And you see in the second set of bullet points, the DP0, the simulated data sets, yep, available now in the RSP. There's actually sort of 2 of them, DP0.2 and 0.3. I'm going to tell you a little bit more about them in a bit. They're basically different simulations for Rubin data. Data Preview 1 will be based on ComCam data that Keith just talked about, and it's coming next year, April, May 2025. And then Data Preview 2 will be based on LSST science camera data. And you can see that's expected mid-2026. And that will be, yeah, all of the data that the team can release from LSST CAM commissioning. So in support for Data Preview 0, currently we can say sort of hundreds of active RSP users. That's sort of the number of people who've logged into the Rubin Science platform and maybe done like 1 tutorial as a minimum definition of active. Fewer numbers are sort of in there writing science papers and stuff based on DP0, and that's fine. This is going to ramp up so that the RSP can support everyone by the start of operations. But right now, we say it's limited, but there is space available. So if you're interested in accessing DP0, even if you only want to do 1 tutorial, that's totally fine. Go to dp0.lsst.io. That's your starting place, and it'll take you through how to set up an RSP account, how to access the tutorials, that kind of thing. I want to mention also that during these data previews, there will also be the First Light celebrations will happen next year once there's some data to make a media event about. So First Light celebrations, it's a large media event. There'll be publicly released pretty pictures, science demos. There'll be celebrations happening, parties, all that kind of stuff will happen. There's a First Light celebration session Thursday that's happening. So, and it's paired with public outreach. So the purpose of First Light celebrations is public outreach. And if you're interested, you can find that session and go to it. Rubin is still discussing sort of a first look at LSST camera data for scientists, sort of after the celebrations happen. Maybe some of the data can be released so that scientists can access the same data sort of in scientific format that went into making the First Light images that everyone saw in the news. Still figuring that out. And the main message is that no matter what happens with that data that makes the pretty pictures for the media, the first like real scientifically validated release of LSST CAM data will be Data Preview 2. That's the big one. That's the one where you can come test your routines, your algorithms, write papers, that kind of thing. All right, so just looking at that in a little more detail, so sort of saying the same thing, DP1 coming April, May next year. And I do want you to notice that the types of data products that will be included in DP1 are limited. It's raw images and processed visit images and the catalog, so sources detected in those direct images only. So a limited data set to start off. And then you can see there when we go to DP2 the next year, you have a lot more different types of data products there. There'll be coads, there'll be sources detected and measured on the coads, and sort of different images and all the catalogs that go along with different images. So keep that in mind that DP1 will be quite limited, and that DP2 is like the first thing that'll be really scientifically useful. So I did say I'd tell you a little bit more about Data Preview 0. The simulated data is in the same format and made accessible by the same tools as will the future real data. So this is where you can come in and start setting up your analysis pipelines, figure out which columns of these massive catalogs are the ones that are relevant to you, and sort of start working through your workflows and start developing your codes that you will then apply to real data. Data Preview 0.2, that's the one you want if you work on stars, galaxies, large-scale cluster, large-scale structure, or in the time domain. So there's variable stars and there's type 1a supernovae. DP 0.2 is for you if that's your science. If you're a solar system, then the DP 0.3 solar system data set is the one for you. It's simulated catalogs of moving objects. Both of these, so the DP 0.2 simulates the data set as it will be at around halfway through the survey, like sort of like at year 5. And then for the DP 0.3, there's actually 2 simulations. One is for year 1 and the other is for year 10. So kind of you can start to plan your early science as if it's year 1, or you can sort of look at what things will be like after 10 years of LSST. There are a variety of ways that we're supporting the community to do science or start to prepare for science with the data previews. One of them is by having the Rubin Science platform available now. So you have 3 options for accessing the data: the portal, the notebooks, and the API. All are up and working now. So if you have an account, you can access all 3. We have all of our documentation at dp0.lsst.io. There's descriptions of the data products. There are tutorials that you can work through on your own pace to learn how to access them, schedules for live events. There's guidelines, known issues are documented there. And eventually something that looks very similar but is for DP1 will exist at dp1.lsst.io, and so on as we move through all the data previews and all the data releases. The third piece of the community science sort of infrastructure is our Rubin Community Forum. It is the place to go. You can go there, community.lsst.org. There's a support category. You click on it, you post a question that you have, a trouble that you've run into, you're not sure how to do something, bug reports, literally anything, pop it in there so that Rubin staff can see it, address it, and get you moving with your Rubin science. And I think this is the last thing I wanted to say, which is just a mention of all the ways, all the related sessions, posters, and talks that are related in some way to Data Preview 0 that are happening at the Rubin Community Workshop this week. So there's a bunch of things, people are in there, they're doing stuff. And then I wanted to call out in particular the community science session on Thursday at 2 p.m. in Redwood. If you're interested in having access to any of this, we'll sort of get you started on that from 0. Yeah, I think I could take some questions.
Hi, thank you. How long is our work in DP0 being held on for? Like, are we guaranteed access to that stuff as we go through DP1, DP2?
Right. So your user drive is not going to be deleted. So we did have a switch in Rubin Science platform and everybody's accounts got migrated, but now that's done. So the account you have now and everything you're storing in there should persist. DP0, I don't remember how long we're going to serve it into. Once DP2 comes, nobody needs DP0 anymore. But I don't know when we actually take it down. So I'm not going to say for sure, but I know that, for example, it's the only way to practice time domain analysis right now is with DP0. That stays true while we have DP1. And so we can't really take it down until DP2 comes.
So we would have some kind of information about when to go and collect all of the things we've been making on DP0.
Oh yeah, we will advertise. So when it comes time to decommission Data Preview 0, there will be advertisements. We will let people know about it. But your everything you saved, like in your Rubin Science platform account, your directories, that all stays. It's just the data set wouldn't be accessible anymore, no longer served.
And then quickly, when does the photo Z stuff get added? At what DP?
Yes, that will be later. So the Photo Z session is happening right now. I scheduled the two things opposite each other. Photo Z sort of, it's not, I wouldn't call it part of the early science program. So we have a team and so we're working on how to validate the various Photo Z estimators. They will be using commissioning data to get that started. DP2 will come. We'll be able to invite the community to come and test different algorithms. We will probably do another round of letters of recommendation so people have time to analyze the various estimators, and then we'll make a decision of what gets used for DR1, maybe 2. Yeah.
And Melissa, left field nosebleeds. Wondering if in the DP 0.2 there are going to be detections of things that are designed to push the bounds of the known detection system. So for example, in the solar system pipeline, it's well understood that there are certain categories of object that will be missed because it's impossible to write a pipeline. So there's a number of people that are interested in like searching for interstellar, seeing finding. Is that sort of thing being considered in the preparation of the DP02 catalog?
No, DP 0.2, the simulation is done. And so it's just variable stars, just type 1a supernova, and that's all we have for now. Nothing will be added to it. Yep. But synthetic source injection pipeline does now exist, so people can inject their own sources into images. So you can do some testing that way. It's still a bit limited, but yeah. All right, I'm around the whole week and always in Slack, so you can ask me questions there. All right.
Be careful what you advertise. All right. Hi, everyone. I'm Eric Blum. I'm the Alert Production Science Lead. I have just a few slides on alerts for early science. You've already heard a little bit of this already. But the takeaway is that our goal is to start sending public alerts from LSSTCam as soon as we are able to, which we expect to be around the end of the LSSTCam commissioning period and the start of the full survey. Once we start producing alerts, we will continue doing so through the 10-year survey. The gating, what we need in order to make alerts is templates. And so we will produce templates from commissioning data where it's available and incrementally then through the subsequent years. So concretely what that looks like is sort of a slow ramp of alerts as the template coverage builds up over the sky through the first year. But our simulations suggest that reasonably quickly, within a few, there's a fairly large part of the sky that will have templates and we'll be getting alerts out. All right, so this is basically saying that about we will have a process to generate incremental templates. We need to have at least at least 3 images sort of an area of sky, modulo some questions around dithering and so on, so we can reject artifacts, make sure we suppress noise. Once we make a template for a given sky area in that first year, we're going to keep it the same until DR1, and that avoids sort of introducing contamination from new transients as well as changing in the baseline, which is difficult to work with when you're doing time domain analysis. And so we're going to be working throughout the ComCam process to refine that procedure so that we're ready when LSSTCam goes on. So if you're curious about, so these alerts are coming through community brokers. And so we have already started integrating those brokers. RTN 10 describes our plans, what we're going to do before we release the first LSSTCam alert. So we're sending simulated alerts. We simulate images, we process them through our pipelines, produce alerts, and send those to brokers. We have done that already in the 4th operations rehearsal and sent them, took simulated images from the summit, sent them to the long haul network here to the USDF at Slack, processed them through prompt processing and alert production, and generated alerts that then went on to the brokers. We are going to scale that up further in the months ahead to full LSST cam scale, so we're ready. Data is there. We will not be sending alerts from ComCam. That's based on both sort of the availability of images. Keith's presentation, I think, suggested how compressed that time frame is, but also we have some preparatory activities we need to do first. So there will be a milestone for LSST cam for first alert release gated by approval by the agencies, and then we will start alert production and continue from there. During that first year before DR1, we may have slightly higher latency, slightly lower purity, and so on than when we have full Sky data release templates. All of the data we send to brokers will be public. All the alerts are public, and you'll be able to get access to the catalog data if you have data rights through the Rubin Science platform. And Melissa and the community science team are going to be prepared to support science users once those alerts are coming out. Again, this is just highlighting both the RSP as an access to prompt catalogs, but also that the community alert brokers, of which there are 7, that will receive the alerts directly from Rubin, and at least two more that will operate downstream will provide user interface to these alert data that are coming off rapidly from the telescope. And finally, I'll just point to the LSST website. There's a section on alert brokers that has more details of what those specific brokers are and some pointers to documentation. So happy to take any questions about this topic, or we can open the floor to general questions. One here, Bill.
Hi, thank you for the talk. Just a question related to the brokers and how they will be interfaced with the Rubin Science platform. Will the user see the classification and the schema within the platform, or they need to access each broker with the graphical interface that they provide?
At this point, I don't think we have any firm plans to bring classifications from the brokers back into the RSP, although it's something that could be considered. So yes, you would need to go to the brokers and use their interfaces to access that information. Michael Strauss and Agnes, do you have the?
Thank you. You said that there would be no alerts from ConCam, but image subtraction will be exercised with ConCam data. Is that correct?
That's correct.
And that's sort of, as it were, purely internal to exercise that system. Is
That's right. And
okay.
and depending, this didn't make the slides. If we had, I think, good enough data in from the ComCam period to support DRP difference imaging, that might make DP1. But we are not going to try to make real-time alerts with ComCam. Meg, would you like to unmute and ask a question?
Sure. So I just wanted to ask about sort of communicating the latency. So I'm just thinking about is if I know that LSST was observing and I don't see alerts, but I'm expecting that like latency may be variable a little bit in early science, how will that be communicated? Are there plans for a website or some status update or something that we can query that would tell us how long it's taking from observation to alert stream? For like the early days of early science, the end of science validation. So we're not freaking out if something's not available and we're like, Rubin's observing, or vice versa, that things are going really smoothly, that it's actually things should be coming in and your broker or your, downstream broker should actually be receiving things.
Yeah, that's a great question, Meg. I think there's a few pieces here. One is the technical question for brokers of, did they understand the status of the observing and data systems? Certainly, I have experience with ZTF, connecting what images were taken to what was processed to what alerts were produced and so on to the brokers. That's a whole chain. And so we have to have you know, dashboards and so on. We're making plans to make those available, and those should generally be, I think, publicly accessible. There's nothing too secret there. The broader question about communicating expectations, I think we should probably talk to the community science team about, you know, what we expect from pipelines, you know, in terms of evolving performance. You know, we expect a distribution of processing time with crowded fields, for instance, taking more time. And so being able to communicate to the community through time what to expect, I think will be important, and we'll find a venue that might be, you know, maybe it's an update on community.lsst.org, maybe it's a different location, but some way to convey that information out as it evolves.
We have plenty of time, so if you want to take a minute to think of any other things that might be coming up, we'll be here. So we're going to continue to work on RTN 11 and the plans, and you will soon hear about how things are going with the commissioning camera. Get LSST cam on Sky. So while I think, you know, we have a good plan for how things should go and what we expect to be able to provide to you, don't be surprised if there's changes along the way, and we'll get data into your hands soon. So I think right now things are looking good. Let's see where we get to. Listen. Go ahead, Meg.
So I just wanted to read something that has sort of dropped out of discussion, which was because there was multiple sort of like scenarios for commissioning and going into science operations. But given that a lot of what's happening in early science, at least before data releases or data previews are out, is time domain or, you know, solar system science with the alerts, is there any possibility of re-examining or thinking about possibly template building observations, maybe not like a dedicated survey, or is that something that's closed at this point, in terms of thinking about boosting the portions of sky that could have alerts, as Rubin's observing post-science validation surveys?
I'm not sure I caught that, but it was the question, are there specific bespoke mini surveys or other observing programs apart from what we've described that might be invoked at some point?
I was more asking about, is it possible to build, will there possibly be consideration of template building observing nights to boost alert production in year one?
I don't have a specific answer for that other than to say it'll depend on how well things go and what time might be able to through those periods that others be going to higher priority commissioning activities.
At least for the purpose of construction completeness, we have not placed full sky template coverage as a criterion for completing the construction project. So our priority is demonstrating that the observatory is functional and would be capable of conducting the LSST. But then, as Bob described, that would have to be a decision of the operations team to decide to do that during the first months.
Okay, well, we'll be around. Come talk to us. Otherwise, you get a little bit extra time for a break and conversation amongst yourselves, and we'll see you at the next session.